Alright, this is video 3 to finish up the test review covering problems 8 and 9. So for 8 and 9, you're asked to find all the zeros, which means the real and the complex zeros. So I'm going to give you first a list of steps to make sure you understand all the steps for finding all zeros. I highly recommend you put this on a note card or a separate sheet of paper. Hint, hint, maybe you'll get to use it tomorrow. So the first thing I want you to do when I give you a function is to graph it. And then from the graph, you should determine how many zeros are real and how many complex. Okay? So for 8a, the degree is 3, so I know that there should be a total of 3. So I'll graph it, and if it crosses once, then I know I have 1 real and then 2 complex. So the second step after graphing, if not every polynomial is factorable, but if it is factorable, I want you to factor and solve. Now, 8a is not going to be one that we can factor. It's cubic where it has all 4 terms, and it's definitely going to be more difficult. But if we take a look at b, what we find is that it's similar to x squared plus 5x minus 36. So that means if you see the one that is in the form ax to the 4th power plus bx squared plus c, then I'd want you to try to factor and solve if possible. However, if it's not, like 8a, I would want you to, from the graph, use the real zero that we found by graphing to create a factor. To create a factor. So for instance, if it crosses the x-axis at -2, then I create a factor always by doing x minus the root, or 0. So in this case, it would be x minus -2, or x plus 2. So that would be the factor right there, x plus 2. If we have x minus 2 equals -2, my factor is x plus 2. Next, what we want to do is long division with our factor and our function. So this factor that we created here, x plus 2, would be your divisor, and you would do long division with your function, which is your f of x. So in this case, for 8a, this is our function. This is all this would go under here. I'll put f of x for your function, okay? And with that, you will do long division. So we're going to work this out using this process in just a moment. And lastly, what you'll find is that when you get done, your quotient should be in the form ax squared plus c, which what that means is you'll have a quadratic function, but your linear term will be missing. So you'll see in a second what that means and what it'll look like. So it's not really a step, but it's something you should pay attention to. So the very last step is to set that quotient that you get when you do your long division equal to 0 and solve it. Okay? So again, for 8a, since you've got 3 zeros, remember complex conjugates come in pairs. So if it crosses once, the other 2 will be complex, and you'll be able to find them by solving this quotient that you get when you divide. So we're going to do all these steps. Step 1 is to graph. So we can see our function there, x cubed plus 2x squared plus 16x plus 32. When we graph it, we see it crosses at -2. So this is not one we would factor and solve because it's not in this form. So step 3 says we use this real zero, which you can see I already used it here. For example, since our x is -2, my factor is x plus 2. So then I'm going to move on to step 4. So you can see you move through it pretty quickly. You just need to think about your process. Step 4 is going to be the longest part. So I'll come down here and say, so for step 4, And if you want, if you're doing this on a note card, I would suggest you put the steps on one side and work this example out on the back. I'm sorry, I don't know why I wrote 4. Oh yeah, because it's step 4. So now we're going to work out 8a using step 4. So it says that we need to take the factor that we created, this x plus 2, because it crossed the x-axis at negative 2, and we're going to set it out here as our divisor. We are then going to put our function f of x under here. Well, from the test review, your function is x cubed plus 2x squared plus 16x plus 32. Now remember your end goal. I told you should end up with just the quadratic and constant term left. So let's get started. Remember, I'm going to assume at this point you understand long division very well. So I'm going to take x cubed, divide by x, and get x squared. Then multiply. Pause if at any time you're trying to write this down and it's going too fast for you. Draw your line, change your signs. Now what we notice here is that 2x squared minus 2x squared gives us 0x squared. Please write it down. You do need this to do your division. When you get to the step where you've brought this down and now you need to divide again, you're going to come over here, write 0x squared, and divide by x. Well, that means one of your x's cancels. So we have 0x. Please put that linear term there, 0x. Then distribute. 0x times x is 0x squared. 0x times 2 is still 0x. Draw your line, change your signs. In this case, it doesn't really matter. Then bring down your plus 32. We're almost through. 16x divided by x gives us 16. Notice it is turning out like it's supposed to because you have your quadratic term and a constant, but your linear term is going to zero out. So let's finish this up. 16 times x is 16x. 16 times 2 is positive 32. Draw your line, change your signs, and it should cancel out, leaving a remainder of 0. One thing that I should point out is your remainder should be 0. Remember, your factor theorem says that if we're evaluating x equal negative 2, then the factor x plus 2 is a factor if our remainder is 0. And in this case, it is 0, which proves that we did our math correctly, that x plus 2 is a factor. And last, we have finished step 4. We need to check step 5. Is it in the form ax squared plus c? Yes, in fact, our quotient is x squared plus 16. Now step 6, we're going to set that equal to 0 and solve. So we're going to subtract 16 from both sides. X squared equals negative 16. Take the square root of both sides, and x will equal positive or negative 4i. So these are the two complex solutions we have. Remember, for 8a, we're dealing with a cubic polynomial. We should have 3 zeros. One of them is real, as evidenced by the graph. The other 2 are complex, and we found those by graphing. So to that, add your other 0, which was negative 2. Put a box around it to indicate that that is your solution for x. Positive and negative 4i and negative 2. I would highly recommend rewinding and watching this video from the start again to make sure that you understand it. Now for 8b, 8b is much easier because it is factorable. So our function is x to the 4th plus 5x squared minus 36. Because it is a trinomial and we can find factors of negative 36 that combine to give us 5, we will write this quadratic function as 2 binomial factors where the first terms are x squared and x squared. And then we have to think, well, what 2 factors of negative 36 can I use to get 5? Well, 9 and 4 might work. In fact, 9 minus 4 will give us 5. But 9 times negative 4 will give us negative 36. So I'm going to have x squared plus 9 and x squared minus 4. So recall that x squared minus 4 is a difference of squares, while x squared plus 9 is a sum of squares. So let's not factor our sum of squares. That's not really factorable in terms of real zeros. So x squared minus 4, remember, factors into two binomial factors that look just alike. One is a sum, one's a difference. The square root of 4 is 2. So you can see this is where we're going to get two of our real ones. So we're going to get two real and two complex. So let's, last step, set our factors equal to 0. So x squared equals negative 9. And when we take the square root of both sides, we get positive or negative 3i. This one down here, we should be able to look at it and tell that it is negative 2, and this one here, be able to tell that it is positive 2. And that's the 4 of our zeros. And actually, if we graph it, we'll be able to check and make sure that that is right. X to the 4th plus 5x squared minus 36. Oops. And when we graph it, it should cross at 2 and negative 2. And it does, negative 2 and 2. And so that means we have the two real and the two complex. And those are your solutions. Lastly, let's talk about 9. 9 says, a research lab is testing a new drug on a patient, and the amount of the drug remaining in the patient's bloodstream T hours after the drug is administered can be modeled by this function P of T. So please keep in mind that your body cleans out anything that you put in it. So basically the drug wears off over time. And so they can actually determine how much you still have in your blood system based on this function for this particular scenario anyway. So the first thing I would want you to do is, of course, graph it. Negative 2t to the third, of course we'll use x, plus 6x squared minus 8x plus 8. And graph it. Now because it's a cubic polynomial, we understand that there should be 3 zeros. But what we notice is that it only crosses the x-axis. It appears one time and at positive 2. So let's check. Do we see the 0.20 on our table? Yes, we do. So that means in that quadrant, the only part that's relevant is when it comes down and hits at 2, 0. So remember, time is here on that x-axis, and the amount of drug within the system is P of T. So that means after 2 hours, there is nothing left in the system. Okay? So all you need to do is find the real 0. And if it crosses at 2, that means that it will be totally eliminated from the patient's bloodstream in 2 hours. Then it says interpret all other roots. So the other roots are the complex roots because clearly it only touched the x-axis one time. So if our x value or t value equaled 2, then we need to find the other zeros by doing long division. But for the sake of the test, I'm not going to make you do one since I already had you do one up here. So you only have to do it once. So just simply state that for the other roots, it has 2 complex roots, but that neither are relevant for the function. Okay, 2 complex roots, neither are relevant for the function. Okay, and that concludes your test review. Good luck.